Hi, today we are going to discuss the topic scalars and vectors. Physical quantities possessing only magnitude are called scalars. Physical quantities which possess both magnitude and direction are called vectors. In that sense, distance, time, speed, work, all these things depends only on magnitude. It has no direction. Mass, time, length, distance or length. Anything which is depending only on magnitude, which possess only magnitude are called scalars. Physical quantities which possess both magnitude and direction. Both magnitude and direction are called vectors. So you have to represent a vector by a line with an arrow mark. Directed line segment, you can say. Velocity, momentum, acceleration, force, etc. All these things depends on direction. So we can say these are the quantities possess both magnitude and direction called vectors. Fine. What is called addition of vectors? Suppose you have vector A and vector B. I want to add head of the first vector and tail of the second vector should coincide. Head of the first vector and tail of the second vector should coincide. Then you can call this one as addition. What is the resultant there? R is equal to A plus B. What is the direction of resultant? Starting point, ending point, join. So this is R is equal to A plus B. Correct? So in the case of addition of two vectors, not necessary it should have only two. Any number of vectors you can take. The condition says head of the previous vector and tail of the next vector should join. Okay. No, sir. First, I want to represent B. Next, I want to represent A. You can represent, no problem. In this case, this is initial, this is final join. See, B plus A. Whether it is A plus B or B plus A, direction and magnitude is same. That means vector addition is commutative. A plus B is equal to B plus A. Vector addition is commutative. Fine. Next. Types of vectors. We have different types of vectors. Collinear vector, coplanar vector, unit vector, orthogonal vectors. Like that, we have many types. Collinear, vectors representing on the same line. Co means similar, same, representing on the same line, collinear. Coplanar, same plane, anywhere. This is a plane, board is a plane. So the vectors representing different directions it may be, but it should be in the same plane. Then you can call it as coplanar. Parallel and non-parallel vectors. See the word parallel, same direction. Non-parallel means opposite direction. Two vectors pointing in the same direction. Sometimes the magnitude may be same, sometimes the magnitude may be different. Same magnitude, same direction, equal vectors. Unequal vectors, anti-parallel vectors. Parallel, same concept, only different types. Okay. Unit vector. Unit vector means magnitude is unity. This is a vector having unit magnitude. How to calculate unit magnitude? Suppose you have a vector A, say force. Force is 5 Newton. Divided by its magnitude. Magnitude of that particular vector you divide. Then that is called as unit vector. You can represent this as A cap. This cap represents unit vector. So 5 Newton divided by 5 cancels 1 Newton. Unit by magnitude is unity, but it has some direction. That is called unit vector. Orthogonal unit vectors. Orthogonal. If we consider three different directions, X, Y, and Z. Along x-axis, I cap, y-axis, j cap, z-axis, k cap. All the three are mutually independent. Independent directions. Every direction on vector, unit vector is indicated. Orthogonal unit vectors. Xi plus yj plus zk. The magnitude may be anything. I cap, this cap represents unit vector. Okay, fine. So these are the basic examples for vectors. Triangle law of vectors. Of triangle law of vector addition. Resultant actual formula we have to calculate in the case of triangle law of vectors. Vector A, vector B, vector A and vector B. So represent A vector, B vector, resultant or vector. Starting point is O, A, A vector. This is B, this is N, perpendicular. Angle between A and B, take it as theta. Angle subtended between the two vectors, you take it as theta. Angle subtended by the vector A with the resultant is alpha. Alpha. So OA is A vector, AB is B vector, OB is R vector. Our aim is to calculate OB. Okay, fine. From triangle BON, this is a right angle triangle. So I can write OB square is equal to ON square plus NB square. OB square is nothing but R square. ON is nothing but OA plus AN, the whole square. OA plus AN plus NB square. Expand this. R square is equal to OA square plus AN square plus 2OAAN plus NB square. OA square value, you know A. You have to calculate AN and you have to calculate NB. So our next step is to calculate these two concepts, these two distances, AN and NB. For this theta, this AN is called adjacent side. For this theta, this NB is called opposite side. So I can write from triangle BAN, sin theta is equal to sin theta. What is sin theta? Opposite side by hypotenuse. What is opposite side of this theta? NB. Hypotenuse means opposite of 90, we call it as hypotenuse AB. So I can write NB is equal to AB sin theta. What is AB? Already we know it is B. So I can write B sin theta. Sir, this B and that B is confusing, sir. You can make any number, no issue. O, P, Q, N, no problem. OP, A vector, PQ, B vector, OQ, R vector. Representation only. So from triangle QPM, from triangle QON, OQ square is equal to ON square plus NQ square. OP plus PN plus NQ square. So you can write R square is equal to OP square plus PN square plus 2OPPN plus NQ square. Equation 1. So, Pn and Nq we have to calculate from triangle QPN. Calculate sin theta. Opposite by hypotenuse. Opposite is NQ. Hypotenuse is PQ. So NQ is equal to PQ sin theta. PQ is nothing but B sin theta. That is B sin theta. Okay, next we have to calculate Pn. This Pn is nothing but for this theta, this is adjacent side. So I can write adjacent side from triangle OPN. Cos theta is equal to, what is cos theta? Adjacent side Pn by hypotenuse PQ. So Pn is equal to PQ cos theta. What is PQ, man? B. So B cos theta. So now you have calculated NQ and Pn. Substitute this NQ and Pn in equation 1. You can find the resultant. Correct? So how to calculate? R square is equal to OP square. What is OP? A square. Pn square. What is Pn? B cos theta. So it is B square cos square theta plus 2OP. 2 OP. OP is A. Pn, that is B cos theta plus NQ square. NQ is nothing but B sin theta. So I can write B square sin square theta. So R will be therefore R is equal to root of A square plus B square cos square theta plus sin square theta. You can take this B square cos square theta, B square sin square theta as B square common plus 2AB cos theta. So I can write R is equal to cos square theta plus sin square theta is 1. So I can write R is equal to root of A square plus B square plus 2AB cos theta. This is the resultant of a triangle law of two vectors of vector addition. Resultant R is root of A square plus B square plus 2AB cos theta. This is the magnitude of the resultant. Sir, I want the direction of the resultant. Anywhere if you find out the direction, if you want to calculate the direction of the vector, calculate tan theta. Calculate tan of the angle with the resultant is made. Okay. So here from the triangle QON, tan theta is equal to, it is not theta, it is alpha. Tan alpha is equal to opposite side by adjacent side, Qn by On. Tan alpha is equal to Qn. What is Qn, ma? B sin theta. We have calculated already and we have taken as equation 2 divided by On. On, how can you write? OP plus PN. That is called ON. OP is A plus PN. PN is B cos theta. So I can write tan alpha is equal to B sin theta by A plus B cos theta. So resultant magnitude is root of A square plus B square plus 2AB cos theta. Resultant direction we have to calculate tan alpha, that is B sin theta by A plus B cos theta. Depending upon theta, this R and alpha value changes. Three cases we can discuss. A and B, angle between A and B can be 0, can be 90, it can be 180. So for theta is equal to 0, theta is equal to 90, theta is equal to 180, you calculate R and tan alpha. R and alpha, in fact, you are calculating. So R is equal to root of A square plus B square plus 2AB cos theta. Tan alpha is equal to B sin theta by A plus B cos theta. Case 1, when theta is equal to 0, theta is equal to 0. Angle between the two vectors is 0. So what will you get? R is equal to root of A square plus B square plus 2AB cos 0. You can write the values. Sin 0, sin 90, sin 180, cos 0, cos 90, cos. Sin 0, 0, sin 90, 1, sin 180, 0. Cos 0, 1, cos 90, 0, cos 180, minus 1. So keep these values in mind. Come back. Cos 0, what is cos 0? 1. So I can write root of A square plus B square plus 2AB. That is nothing but root of A plus B the whole square. Root of A plus B the whole square means A plus B. That is A plus B. Two vectors pointing in the same direction, A and B. According to vector addition, it is A plus B. Second case, here tan alpha we have to calculate. Tan alpha is equal to Q B sin theta by A plus B cos theta. B sin theta, B sin 0 by A plus B cos 0. Sin 0 is 0. 0 by A plus B. That's all we know. We are not interested. Tan alpha is equal to 0. Tan of what angle is 0? Tan 0 is 0. So I can write alpha is equal. Okay. Tan of 0 is 0. Case 2. When theta is equal to 90, this is A vector, this is B vector, both are perpendicular to each other. So formula R is equal to root of A square plus B square plus 2AB cos 90. What is cos 90 here? 0. So this is 0. Root of A square plus B square. This is Pythagoras theorem. Closing side of a right angle triangle is sum of the squares of the two vectors. Root of A square plus B square. Tan alpha B sin theta B sin 90. Sin 90 is 1 by A plus B cos 90. Cos 90 is 0. So B by A. So alpha is equal to tan inverse of B by A. If you know the value of B and A, you can calculate the value of alpha. Using the logarithm table, you can calculate. And third case, when theta is equal to 180 degree, 180, this is A, opposite direction B, opposite direction is B. So R is equal to root of A square plus B square plus 2AB cos 180. Cos 180 is minus 1. So I can write minus 2AB. That is A square plus B square minus 2AB means A minus B the whole square within the root. That is A minus B. Subtraction of two vectors. Subtraction. Here addition. You put vector, here also vector. Vector sign, if you want to represent, everywhere you have to represent. Sir, why you are putting A minus B? It can be B minus A also not there. Definitely it can have. If A magnitude is greater compared to B, you have to write A minus B. If B magnitude is greater, you can write B minus A. Correct? Next, tan alpha. B sin theta by A plus B cos theta. B sin 180, sin 180 is 0. So denominator, anything we need not worry. A plus B cos 180, you will get A minus B, but that is nothing but 0. Alpha is tan of something is 0, that is tan 0 is 0. So these are the three cases for the triangle of vector addition. Magnitude of the resultant is R is equal to root of A square plus B square plus 2AB cos theta. And the direction of the resultant is B sin theta by A plus B cos theta. Depending upon theta value, we can calculate R and alpha. Correct? This is triangle law vector addition. Very important question. So next topic you are going to see is resolution of a vector. Suppose the vectors are pointing in different directions. What is a component of the vector along x-axis? What is a component of a vector along y-axis? It is not exactly in horizontal or vertical. Some other direction it has kept. Say for example, origin, x-axis, y-axis. This is vector A making an angle theta. I want to calculate the A vector along x-axis, the component of AX, the component of A along y-axis, AY, I want to calculate. That is called resolution. I want to represent R vector, sir. No problem. Rx, Ry. A, B, C. Rx I want to calculate. Ry I have to calculate. From triangle BOA, calculate sin theta. So if we calculate sin theta, it is opposite side BA by hypotenuse is OB. BA is equal to AB or BA, no problem. OB sin theta. What is OB? R. So BA and OC are equal and parallel. So I can write this as RY. Ry is equal to R sin theta. If you want, you can put a vector sign. Similarly, the component of R along x-axis I want to calculate. For this theta, this OA is nothing but adjacent side. Opposite side, perpendicular side, if you want to measure means sine. It depends upon theta where you are taking. Similarly, from triangle BOA, cos theta is equal to, what is cos theta? Adjacent side by hypotenuse, OA by OB. OA is equal to OB cos theta. That is, OA is nothing but Rx. OB is nothing but R. R cos theta. Vector you can represent. So, x component of the vector R is R cos theta. Y component of the vector R is R sin theta. Any vector you take is x component in terms of cos theta, y component in terms of theta. Suppose if we take here as theta, this will become the adjacent side, this will become the opposite. For this theta, this is opposite, this is opposite, this is also opposite. So it depends where you are taking theta. Not necessary along x-axis every time is cos component. No, it depends upon the theta value. Okay, theta, how you are representing? Sir, I am taking the vector R. Component of vector I have calculated. That is called resolution of a vector. By calculating the components, the originality of the vector should not be altered. It is not altering here. Same R vector only you are getting. Even though you are writing x component as r cos theta and y component as r sin theta, the original R is not changing. You can verify. From triangle BOA, Pythagoras theorem, OB square is equal to OA square plus AB square. What is OB? R square. What is OA? OA is nothing but R cos theta. R square cos square theta. AB square is nothing but OB sin theta. That is R sin theta. R square sin square theta. So I can take R square outside. Cos square theta plus sin square. Value is not changed. Same value. Okay, fine. Multiplication of a vector. Multiplication of a vector by a scalar. Division of a vector by a scalar. Say I have a vector A. You are multiplying this by 5. Resultant is a vector. 1 Newton. Multiply by 5, multiply by 10, multiply by 100. Everything is a scalar. But Newton is a force. It depends upon the direction. So by multiplying some number, it cannot be changed as a scalar. It is a vector only. So multiplication of a scalar in vector, resultant is a vector quantity. A vector by 5, division of a scalar in a vector, resultant is a vector. 10 Newton divided by 5. 2 Newton. Newton has got force direction. It will not change. So by multiplying a number or dividing a number, the resultant is only a vector quantity. Okay, fine. Now, scalar product of two vectors. What is called a scalar product, otherwise known as dot product. A vector dot B vector. You can take this as scalar product or dot product. The resultant is modulus of A, modulus of B cos. So resultant R is a scalar. Even though you are multiplying by a scalar product two vectors, the resultant is a scalar quantity. It is not a vector. Example, work done F dot S. That is Fs cos theta. Force is a vector quantity. Displacement is a vector quantity. But resultant work done is a scalar quantity. Okay, fine. We have some properties of scalar product. Few properties we will discuss. A dot B is equal to B dot A. A dot B is equal to B dot A. That means scalar product is commutative. A dot B, AB cos theta. B dot A, BA cos of minus theta, because you are changing A dot B to B dot A. Cos of minus theta is nothing but cos theta. So A dot B, AB cos theta, B dot A, BA cos theta. Both are same. The resultant is same. So it is commutative. A dot B plus C is equal to A dot B plus A dot C. Associative property. Associative property. Okay. A dot A cos 0 is 1. So I can write A square. Two vectors pointing in the same direction. Equal vectors, you can call this one. A dot A is A square. Cos 0 is 1. Theta is equal to 0. For perpendicular theta 90, A dot B is equal to AB cos 90. That is 0. Resultant is 0 for two vectors which is perpendicular. Two vectors perpendicular. Same vector A dot A means you have said it is 0. A and B means it is A square and this value is 0. Okay, fine. Sir, I am representing IJK, XYZ, I cap, J cap, K cap. So you are representing I dot I, J dot J, K dot K. I dot I, same vector means what is the answer? A square. So I dot I, this is unit vector, this is also unit vector. So the resultant is 1. I dot I, J dot J, K dot K, the value is 1. Suppose I dot J, J dot K, K dot I dot J means these two are perpendicular. J dot K, these two are perpendicular. K dot I, these two are perpendicular. So the formula says AB cos theta cos 90 is 0. So the resultant is 0. Vector AXI plus AYJ plus AZK. B vector BXI plus BYJ plus BZK. Calculate A dot B. AXI plus AYJ plus AZK is A vector. BXI plus BYJ plus BZK. That is B vector. A dot B I want to calculate. AXI dot BXI. I dot I is 1. So AX BX. I dot J, I dot K 0. AYJ dot BXI, J dot I 0. AYJ BYJ, AY BY. Because J dot J is 1, remaining two quantities 0. Similarly, if you multiply AZK with BXI and BYJ, it is 0 only. Because theta is 90. Here around you will have theta is equal to 0. So A is Z, B. So these are the few properties in the case of scalar product of two vectors. Now we'll go for vector product of two vectors. Vector product, otherwise known as cross product. Vector product or cross product. A vector cross B vector, modulus of A, modulus of B, sin theta, n cap. Sir, modulus of A, modulus of B, sin theta is a scalar quantity. A vector cross B vector, resultant is also a vector. So resultant is R vector. How will you represent that vector in the resultant here? So we are multiplying by unit vector. So unit vector shows only direction. This is the magnitude. AB sin theta is the magnitude. N cap will give you the direction. So in scalar product, the resultant is a scalar. In vector product, the resultant is a vector. Example, torque. Torque is a vector quantity. R cross F. R cross F means R is the displacement, F is the force. Both are vector quantities. Okay. A, some properties we will write. A cross B is not equal to B cross A. Why? It is not commutative. Because A cross B means AB sin theta n cap. B cross A means BA sin of minus theta n cap. Sin of minus theta is minus sin theta. So I can write A cross B is equal to minus B cross A. No problem. Anti-commutative. Opposite. Minus sign is coming, so opposite. Okay. Next. A vector cross A vector. Same direction. Theta is equal to 0. When you say theta is equal to 0, sin 0 is 0. So resultant is 0. A vector cross B vector. Suppose A and B perpendicular. Root of A square plus B square. Pythagoras theorem. So AB sin 90. Sin 90 is 1. So resultant is modulus of A, modulus of B, sin 90. Sin 90 is 1. So it is AB. A plus B means you can say A plus B means you can say resultant is like this closing side of the triangle. Here cross product of two vectors. Cross product. Perpendicular. Theta is equal to 90. So AB. What is the direction, sir? Here you told torque is equal to R cross F. Displacement one direction, force another direction. Which direction the resultant torque will act? Excellent point. When you say two vectors A and B making an angle theta, A cross B, I want to calculate. Formula definitely you know. AB sin theta n cap. Direction. I will tell. Suppose same BA. This is theta. B cross A you want. Direction. Minus A cross B. B cross A is minus A cross B. Direction. For that, thumb rule. Extend the right thumb. The direction of curling of finger represents A cross B. A cross B. See the resultant direction. Upwards. N cap. This is the A, B cross A. Downwards. Resultant. Corkscrew rule. Rotate. Rotate the screw. Like this. Clockwise you are rotating. Which direction screw is going? Downwards. So clockwise means downwards. Clockwise, resultant is downwards. Anti-clockwise, resultant is upwards. You can remember these two. Thumb rule and corkscrew rule. Direction of vector in the resultant. Okay. Fine. Next. I cross I, J cross J, K cross K. Entire family is 0. Why? I cross I. Theta is equal to 0. Theta is equal to 0 means sin 0 is 0. So I cross I, J cross J, K cross K is 0. I, J, K. I cross J, K cross J cross K, K cross I. I cross J, J cross K, K cross I. I cross J, next is K. J cross K, next is I. K cross I, next is J. What is not there, you write. What is not there, you write means in order if you write, the third one will be the resultant. Sir, suppose I am having I cross K. What is not having here? J. But if you write J, the answer is wrong. Because I, J, K, clockwise order. You are skipping this J. So, minus sign. K cross J minus I. After K, I only should come. But you have skipped. So, minus. Next. J cross I minus. Correct? An important property. Important property in the case of scalar product of two vectors. A vector is equal to AXI plus AYJ plus AZK. B vector is equal to BXI plus BYJ plus BZK. I want to calculate A cross B. Right as a determinant in maths, you might have come across I, J, K. AX, AY, AZ, BX, BY, BZ. Now resultant we have to calculate. AX, I cap. Leave this column, leave this row. Cross multiply the opposites. AY, BZ minus BY, AZ. I cap. Plus, minus, plus. Minus J cap. Leave this column and this row. AX, BZ minus BX, AZ. And third, plus K cap. Leave this column and this row. AX, BY minus BX, AY. This is the result. Sir, here I want to put plus. Very well, you can put plus. Interchange. If you put plus J, it should be BX, AZ plus J. BX, AZ minus AX. Change. Change. This is the resultant. Cross product of two vectors. So these are called examples or properties of vector product of two vectors. So we have seen what are scalars and vectors, examples for that. Then types of vectors we have seen. Vector addition we have come across. Triangle law in vector addition. Very important 5-mark question is that we have discussed. Then the most important scalar product of two vectors and their properties. Vector product of two vectors and the properties. Correct? So these are things we have discussed. And in between we have discussed component of a vector, that is called resolution of a vector. How to resolve the vector A or vector R into two components. Okay. Thank you. We'll continue.